Hi guys, this video is to show us how to interpret correlation analysis in few minutes. First of all, I'll be using the time series data of GDP, which is gross domestic product, and DCF, gross capital formation from year 2010 to 2021. This is just to demonstrate on how to interpret correlation analysis or correlation result. This is a Excel file, and I'll be using Excel and SPSS to demonstrate the analysis and then come to words to show you the interpretation of the result. First of all, looking at the data, you can see that the data is so large. They are in normally this data is collected in billion, both in billion. DCF2 is also in billion, but it's looking like the data is so big. So the first thing we usually do in statistics when we are dealing with a large data, a data that is so big, the observation is so big, try to what to normalize data to obtain valid outcome, valid result. So in terms of normalizing it, we use log transformation. We transform the observation, the values, so as to shrink the value to small observations, to small values. And we'll be using log to do that. Here, just look at how I'll be going through the transformation of GDP is equals to lean, that's log of log 10. Select 10, then come here, and this I've obtained the log of the GDP. Also log of GCF, also the same thing, log 10 of this, and then do this. So we have already obtained the two variables that we need, the log transformation of the two variables that we need. I'll first demonstrate it in Excel, how to obtain the correlation results in Excel. Then come to data, this data, then for Excel of 2016, Microsoft of 2016 and above, this data analysis toolpack will be already installed there. Whereas version of below 2016, you have to add it. You go to the adding and adding it into the Excel. So press this, come to correlations. You can see correlation, then press OK. Then here, selecting the variables that you need. Come here, select these two variables. Then column. Yes, we are grouping by column. Then label, you have to check the columns, the labels in the first row. Check it. Then where do you want your output to be? So I want my output to be here. To be here. Sorry, mistake. This. Yes, yeah, my output. You have to click here. Output range. So I want it to be here. That's where I want my output to be. Then press OK. So I can see. Uh, this is the result. Result is 0.998 in Excel. This is the result is 0.998 of this one. That's 0.998. But another way of doing it, there's one thing that we did not get here, which is the the p-value of the estimate. So you can look at the result, like the value, the correction value is so high, 0.999. 0.999 is so high, or that shows that there is strong correlation between them, and that's it. Another way to get the p-value, because correlation analysis in Excel will not give you p-value. So you have to get the p-value by running regression analysis. So through the regression analysis, you get your p-value. But me, I mostly like to use SPSS. So SPSS will just give us the results once. So taking this data to SPSS, let's see. So this is data. Look at this. This is the same data that is there. You can see it here too. So the same thing, the transformation I did to the data in Excel, I want to do it here too. You can as well do it here in XPSS too. What do? Just come to transform, then compute variable, then come here, you can see compute variables. This is how to do it. What do you need? We need the log transformation. So you come to the arithmetic side. This is arithmetic. From there you click on the log, then you drag it up, and you insert this into it. So this will give you log of what GDP. Then you can as well name it log GDP, and then you press OK. So this will not get it for you, will obtain it for you in this is here. Likewise, the same thing, you do the same thing for this, you do the same thing. Um, Transform, compute variable, same thing again, just change it, just change this to GCF, log GCF, then come here, then GCF, then run it again. So you get same thing here too, you get the same thing. So what do we need now? It's now to run out our correlation analysis. From there, run our correlation analysis, correlation, and see you have this here, and click this to here. That's the two variable that we need. Then that's what guessing, correlation, to details, and that's what. Press OK. And this is the results. You can see the results. But there is one thing you have to notice. The result of this here, this is the correlation coefficient. That's 0.699, and the p-value, the sig value here is our p-value 0.011. Look at it here. The result of this correlation is different from the result of this correlation here. And the same analysis that we want the same correlation, same analysis that we want. Or let's try, let me try another way of wanting correlation here. Correlation by only this cover of our this. You can see comma and this, and close the bracket, press OK. So see, you can see it's still bringing the same thing, still bringing the same as 0.998. Why the result of the regression is bringing us different one? So you have to be specific. That's why the whenever in the statistical research methodology of any project, we have to identify that this is the tools that we use. That's how it is very necessary to identify. State there that we use SPSS to carry out the analysis, we use Excel to carry out the analysis, because I think they have different, some have different algorithms, but many times the answer should be the same. Many times the answer should be the same. But in this case, the answer is different. I don't know why. But looking at the results here, the results of the analysis is here, and everything I need is already given to me. I need what? I need the correlation coefficient, the p-value, and as coming towards the I copy the result to Word. This is the same result we obtained. Correlation have three three things that you have to explain. You have to explain the strength, you have to explain the direction, and as well have to explain the significance of the result. This is the result. The correction coefficient is 0.699. The direction of this correction is what is positive, is positive direction. That's why there is a positive relationship between GDP and gross capital formation. Likewise, looking at the value, I'm using this scale here from 0.1 to 0.49, which implies weak correlation, 0.5 to 0.7, which implies moderate correlation, 0.8 to 0.99 implies strong correlation. Some some textbook we use 0 point from 0.1 to that's I'm using modulus here. That is negative and positive because result of correction ranges between -1 to plus +1. So I'm using the modulus here. So some textbooks use 0.1 to 0.49 to be weak or low correlation, and then from 0.5 to 0.779 to be strong correlation, to be moderate correlation as well. We have weak, we have moderate, we have weak, we have moderate, and we have strong correlation. So, but some, this is the majority of the textbook use this. Majority of textbook use this, but some also classify it into like four categories. We have, I think we have weak, low, weak. Some also use what? Let us go with this one as majority use. So I'm using this one as well. Implies on our results, which is 0.699, fall within the window but of moderate correlation. So this also indicates that there is a moderate correlation between GDP and GCF. What I was trying to say before that some feel like there is no any perfect correlation. That's one when we have one. Okay, coming to this place, how do you interpret this? So the interpretation says that the correction coefficient value it implies that there is a positive and moderate relationship between positive and moderate relationship between gross capital for products and gross domestic product and gross capital formation GCF. That's the interpretation of that. Why the p value is 0.011 of the estimate indicates that the correction coefficient is significant at 5% level of significance. So can also at 10% level of significance, the estimate is also significant. I want you to like this video as well, share this video, also comment on the in the comment section. Whatever you want to say, please comment in the comment section and I'll respond to that. Thanks so much for watching.